Let us find out the interval of convergence of an infinite series which is given by x minus x square by root 2 plus x cube by root 3 minus x raised to 4 by root 4 plus etc. Notice that this is an example for power series of the form summation n ranges from 0 to infinity a n x raised to n. Here we have the general term will be un equals minus 1 the whole raised to n minus 1 multiplied to x raised to n upon root of n, and an equals minus 1 the whole raised to n minus 1 upon root n. Recall that interval of convergence of a power series is interval inside which the given power series will converge for all set of values of x and outside which the power series will diverge. In order to find out the interval of convergence, we will depend on ratio test. That is, we will have to evaluate limit n tends to infinity modulus of un upon modulus of un plus 1. We have un equals this expression, therefore modulus of un will be the absolute value of un, which is x raised to n whose modulus upon root of n, which can be considered as modulus of un equals modulus x the whole raised to n upon root n. Here when you replace n by n plus 1, you will get modulus of un plus 1 equals modulus x the whole raised to n plus 1 upon root of n plus 1. When you consider the ratio modulus un upon modulus un plus 1, you will get this expression upon this expression. We have modulus x raised to n upon modulus x raised to n plus 1 will give us 1 by modulus x, and 1 by root n upon 1 by root of n plus 1 will give us root of n plus 1 upon n, which can be written as 1 plus 1 by n the whole raised to 1 by 2, or root of 1 plus 1 by n. Now we will apply limit n tends to infinity to the expression modulus un upon modulus un plus 1. That is, limit n tends to infinity root of 1 plus 1 by n multiplied to limit n tends to infinity 1 by modulus x. Here, since there are no terms involving n, this limit has no effect on this term. Here when you apply limit n tends to infinity, it will become 1. This is because limit n tends to infinity 1 by n equals 0, and when this limit is applied to this term, you will get 1 as the answer. Therefore, limit n tends to infinity modulus un upon modulus un plus 1 equals 1 by modulus x. Recall that by ratio test, whenever limit n tends to infinity un by un plus 1 is greater than 1, then we say that the corresponding power series or the infinite series is convergent. Therefore, to find out the interval of convergence, the necessary condition will be that this particular value, which is the limit of un by un plus 1, must be greater than 1. Or we have set of all values of x for which limit n tends to infinity un by un plus 1 happens to be greater than 1 will give us interval of convergence. We have for the power series to be convergent, 1 by modulus x must be greater than 1 as per ratio test. This inequality is equivalent to modulus x less than 1. From here it is clear that this is the situation wherein the given infinite series will converge, and therefore outside this disk or corresponding to the inequality modulus x greater than 1, we have the given series will diverge. Now we will analyze the situation at x equals 1. When you give x equals 1 in the given infinite series or the power series, it becomes 1 minus 1 by root 2 plus 1 by root 3 minus 1 by root 4 plus etc. At x equals 1, the given power series becomes an alternating series, that is a series with positive and negative terms which occur alternatively. First term 1 is positive, second term 1 by root 2 is negative, the next term 1 by root 3 is positive, the next term 1 by root 4 is negative, and so on. Whenever you have an alternating series, you have to check whether the alternating series is convergent using Leibniz test. Leibniz test says that the following two conditions will ensure the alternating series will converge. The first condition will be un greater than un plus 1, which means that the nth position term must be greater than the succeeding term in numerical value. For example, here we have 1 is strictly greater than numerical value of 1 by root 2. Similarly, 1 by root 2 is numerically greater than numerical value of 1 by root 3. 1 by root 3 is strictly greater than numerical value of 1 by root 4, and so on. Even if negative terms are seen in the series, we will consider the absolute values when you check for the first condition. The second condition will be limit n tends to infinity un equals 0. For this series, we have the general term un will be 1 by root n, and when you give limit n tends to infinity to this general term which is 1 by root n, you are obtaining the limit as 0. Since these two conditions are satisfied by this series, it guarantees that at x equals 1, the given power series will surely converge. We will analyze the situation for x equals minus 1. From ratio test, for modulus of x less than 1 and for modulus of x greater than 1, we have obtained a quantity on whether the given series will diverge or converge. When you consider the situation modulus of x equals 1, you will get two cases, x equals 1 and x equals minus 1. Corresponding to x equals 1, we have obtained that the power series will surely converge. When you give x equals minus 1 in the given power series, for x equals minus 1, this power series will become minus 1 minus 1 by root 2 minus 1 by root 3 minus 1 by root 4 minus etc. The given power series for x equals minus 1 becomes minus times 1 plus 1 by root 2 plus 1 by root 3 plus 1 by root 4 plus etc. Or it can be written as the power series at x equals minus 1 becomes minus 1 times summation n ranges from 1 to infinity 1 by n raised to 1 by 2, or minus 1 times summation n ranges from 1 to infinity 1 by root n. This series is of the form summation 1 by n raised to p whenever we have p is greater than 1. That is, when p is strictly greater than 1, the power series will converge, but here we have p equals 1 by 2. Since p is strictly less than 1, we will conclude that by p test this series will diverge. Therefore, for modulus x less than 1 and for x equals 1, the given power series will converge. Simultaneously, we have for modulus x greater than 1 and at the point x equals minus 1, the given power series will diverge. Therefore, the interval of convergence will be x belongs to open minus 1 comma closed 1. For all x values belonging to this interval, the given power series will converge.